All right, welcome to the last part of lecture 27, part C. In this part, we're going to talk about actually figuring out how much stuff do you need to make up a solution. So it's kind of related to the last part. There's going to be a little math involved. Now, you might remember in the last part, we started off talking about, or we were talking about molarity. So let's start off with a little review question. What is molarity? Molarity is defined as, oh, one of those is right. Molarity is defined as, is it A, B, C, or D? It is A. Molarity is a way of talking about the concentration of a solution. Specifically, it's how many moles of stuff did you put in every liter of water? How many moles of some solid, typically, did you dissolve in every liter of water? So when we make up a solution, not always, but usually we're talking about dissolving a solid in water. So like, for example, you can make up a salt solution. If you took 58 grams of salt, which, that's a mole of salt actually, and you dissolved it in a liter of water, you would have a 1 molar solution. So you used 1 mole of salt and you put it in 1 liter of water, you make a 1 molar solution. All right, so far what we've done in that last part is I said, hey, you take so much of something, you put it in water, what's the concentration? So we've been solving for the concentration. Are you going to end up making a 5 molar solution, a 3 molar solution, a 20 molar solution? Now what we're going to do in this part is we're going to kind of think about what's going on, but go in the other direction. And what I want to do is I'm going to tell you you need a certain molarity. You want to create a certain concentration. And we're going to try to figure out, well, how much solid, how many grams of solid would you use to end up with a certain concentration? So it's similar to what you saw last time, except we're kind of going backwards. I'm going to ask you how many grams you need to make up a solution. Now, the math, it's a little different. It's going to involve still our molarity equation, but we're going to have to think through it a little bit differently. All right, so with that, let's get to an example. All right, so it says here, how many grams of, well, I guess that's NH4OH, that's ammonium hydroxide. How many grams of ammonium hydroxide would you need to prepare 2.5 liters of zero point 0.1 molar ammonium hydroxide solution? All right. How many grams of ammonium hydroxide would you need to prepare 2.5 liters of zero point 0.1 molar ammonium hydroxide solution? So really what we're trying to figure out this time is we know what concentration we want to make up. So maybe for our experiment to work or for this chemical to do what I want it to do, I need to end up with a 0.1 molar solution. So I'm going to end up wanting to make 2.5 liters of it. So that's quite a lot. So what I'm trying to figure out is how much of this ammonium hydroxide, how many grams of it would I need to dissolve in the water? I guess you would use 2.5 liters of water. How many grams of this stuff would I need to weigh out so that when I toss it in the 2.5 liters of water, I end up with a 0.1 molar solution? So I know the concentration I'm aiming for. I'm trying to figure out what weight of this solid do I need to use to make that concentration. So this is actually probably a more useful example than what we did before, because often when you're doing an experiment, you're going to know that, hey, I need a 1 molar solution to do it, or I need a 3 molar solution, or I need a 2 molar solution. So we're trying to figure out, well, how do we make that concentration? All right, so it's involving molarity. So we're still going to be using the molarity equation. Molarity is moles over liters. And if you look at what I've given you, it says how many grams, well, we'll get to that in a minute, would you need to prepare 2.5 liters, oh, okay, I got the volume, I got the liters, of 0.1 molar, so I know the molarity solution, 0.1 molar ammonium hydroxide solution. So if you look at this equation, we've got the volume, we got liters, we got molarity. So what we could do with this equation is we could do a little algebra. We'll have to do a little rearranging in a minute. But I can use the numbers I've told, and I can solve for moles. Now, I didn't really ask you for moles, right? The question says how many grams. But moles and grams, they go together. They go together all the time because they're connected with the periodic table. So we can use this equation to find moles. And then once we do that, then we'll bust out our periodic table and we can get to grams with our periodic table to see the weight we're going to use. All right, so that's kind of the outline of how we're going to do it. Let's go ahead and try it. So let's find how many moles we need, and then we'll convert it to grams. All right, so molarity. Oh, they tell me that. Thank goodness. We're making a 0.1 molar solution. Moles. I don't know. We're solving for it. All right. And then they tell me the volume in liters. Liters, 2.5 liters. So I know L, 2.5 liters down there. Now, what I'm going to do, I got to solve for moles. So we've had to do this with other formulas. I said, man, if there's ever a fraction, let's get rid of this fraction. So if I'm trying to solve for moles, the way I want to solve for moles is I need to move the 2.5 liters to the other side. We usually call that cross multiplying, right? That's what we're going to do now. So we're going to multiply both sides by 2.5 basically. We'll end up with this. 0.1 times 2.5 will equal how many moles we need. All right. Now, if we work it out, what you're going to end up with is 0.1 times 2.5. That'll turn out to be 0.25. Now, I want to point out one more thing. I've told you, okay, yeah, you got to round and all that stuff, but I've also been telling you all semester, your units should always work out. So you might be looking at this and going, well, I don't get quite how these units are working. An M times an L makes moles? How's that? Well, let me explain that to you. All right, the reason why that's true is remember what capital M really is. Or another way you could write it, we could say, capital M is moles over liters. So if you multiply it times liters, do you see how the liters would cancel? And we're left with moles. So that's why what we're doing works out. Not only the numbers work out, yeah, the units work out. They always have to work out. So yeah, 0.1 molarity times 2.5 liters, we need 0.25 moles. Now, let's be a little clearer. We need, I guess I'll keep working up here. We need 0.25 moles of ammonium hydroxide. All right. So that's not quite the answer, though. I want to know what's the weight. How much solid are you going to get? So what we're going to have to do next is once you know moles, how many moles you're going to get, we're going to have to figure out how many grams that is. So now we're ready to go from grams to moles. Man, we've done this before. It is periodic table time. All right, moles to grams, the periodic table. Now, that means I need to add up the weight off the periodic table. I kind of ran out of a little room here. Let's see. I guess we'll do it up here. 1 nitrogen, and there's actually 5 hydrogens and 1 oxygen. Nitrogen, oxygen, hydrogen. One of these fellas. 5. Oh, how did I write that? Sorry. 5 hydrogens and 1 oxygen. Shoot. If you add it all together, let me just tell you what you come up with, because I'm kind of running out of room there. The total works out to be, well, I got a little over 35 when you add up the weights off the periodic table. 35.05 grams equals a mole. So if you look at what we are at, we figured out a minute ago we need 0.25 moles of ammonium hydroxide. If you're trying to go to grams, you got your conversion factor is 35, and the way it should work is if you multiply, it should work. You'd put the 1 mole on the bottom, the 35 should go on top. So you need 8.8 grams of ammonium hydroxide. All right, we'll do another one in a sec, but hopefully this is making sense. So basically, if you got 8 grams of this solid, 8.8 grams of it, you tossed it in 2.5 liters of water, you would make a 0.1 molar solution. All right, so big idea. How do we figure this out? Well, you use your molarity equation. You figure out how many moles you need. And once you know how many moles you need, you can use your periodic table to figure out how many grams you need. All right, let's try one more. Let's try one more. All right, it always helps to see another one. All right, one more example along these lines. All right, so this one is a question. It's kind of related to actually one of my favorite movies and one of my favorite books. It's this book, you might have read it at some point in your life. It's called Into the Wild. It's about this guy who's hiking in Alaska, and he eats some berries that cause him to vomit a lot, and he can't keep down any food. And then he gets stranded in this abandoned school bus in Alaska, and he can't eat anything because the berries made his stomach vomit up any food. So he's sitting there, and sadly he dies. He dies of starvation because he can't keep any food down. There's a lot more to the story, but that's the basic idea. Now, let me just tell you, when I read that story, I go, well, gosh, is there any way he could have saved himself? Because he couldn't eat any food, so he ended up starving to death. So is there any way he could have gotten, some energy some other way? And there is one other way you can get energy. If you can't keep any food down and you're in the hospital, they give you an IV. So let's imagine you're stuck somewhere and you can't eat anything. So your only hope at living is to make up your own IV. Your own IV. And again, I admit this is not a super realistic story, right? So in this imaginary fairyland, you happen to have an IV bag and a needle and a scale and all this stuff, all right? And not only do you have that, you also know, based on your chemistry class, I'm saving your life right now, that to make up an IV, any IV that you get in a hospital, it has to be just the right concentration or it'll kill you. So the concentration that they always give you, it's the same concentration as you have normally in sugar in your bloodstream, which is 0.31 molar. If you make up an IV or somehow you get an IV and it's not that molarity, your blood cells will expand or shrink and you'll die, all right, from it. It'll rupture your blood cells. All right, so let's pretend you're stranded in the mountains and your life depends on you knowing how to make up this IV. So we're going to make up an IV. I know the concentration I want, 0.31 molar. It has to be that concentration. Your life depends on it. And we're going to make it by dissolving some sugar in water. So we want to figure out how much sugar am I going to need. So my goal again in this question is it says how many grams of sugar, sugar is C6H12O6, how many grams of sugar would you need? You want to make up 4.5 gallons of an IV. You figure that'll last you a few days. And it has to be 0.31 molar. How many grams of sugar do you use? How many grams of sugar? So you're going to dissolve so much sugar in that 4.5 gallons of water to create your IV. Your life depends on it. All right, so let's figure it out. Now, I know I need 0.31 molar. This question involves molarity, right? Molarity is moles over liters. So what I need to really figure out, kind of like we did a minute ago, is I really want to figure out how many moles of sugar we need. Because once we know how many moles of sugar we need, we can see how many grams that is. Because you can go from moles to grams with your periodic table. All right. So to figure out how many moles we're going to use, we have the molarity, oh yeah, it's going to be 0.31. But there's one other issue that we didn't have last time. We're going to figure out how many moles we need, but we also need to put in this equation how many liters you're planning on making up. Now, I didn't give you the volume in liters. I gave it to you in gallons. You're going to make up 4.5 gallons of solution. So you cannot put 4.5 down here on the bottom because that's the wrong unit. Gallons is the wrong unit. So what do we have to do first? Convert gallons to liters. All right, so let me remind you, we haven't done this in a while, but gosh, we did learn how to convert gallons to liters way back in the day. Let's see, we'll do it over here. 4.5 gallons is what we have. We need to convert it to liters. The conversion factor, oh, you could look it up on a handout from weeks ago. I'll just tell it to you, save you a little time. 3.785 liters is 1 gallon. All right, think about it. Gallons to liters. Multiply by 3.785 or divide by 3.785? Multiply. You have to multiply. You'd put the 1 gallon on the bottom. You put the 3.785 on top. So you actually plan on making up, if you work it out, 17 liters of solution. All right. So now we should be in business. So molarity is moles per liter. We already, a minute ago, put in the molarity we're aiming for. You now know you are aiming to make 17 liters. So we'll put 17 liters on the bottom, and we're going to figure out how many moles we need. How many moles of sugar? So we're solving for moles. So kind of like I did a minute ago in the last example, you're going to cross multiply to get moles alone. Probably I should have an M there. So when you work it out, you need, if you multiply 0.31 times 17, you are going to end up needing to use 5.3 moles of sugar. So you're going to get 5.3 moles of sugar and stick it in all that water. Now, again, that's fantastic, but you can't tell me 5 moles. You're not going to have a mole scale. You're going to want to know how many grams that is. How many grams of sugar are you going to get? So we got one more thing to do. Let me erase a little bit of this. This is how many moles of sugar. So we got to now go from moles to grams. We're going to use our periodic table. 5.3 moles of sugar. And that's C6H12O6 is how many grams of sugar. All right. Hey, you know what? Instead of watching me do all the work, why don't you figure it out? How many grams is that? All right. I'm going to let you work on it. Then we'll see if you get it right. How many grams of sugar do you need? Moles to grams. Oh, I hope you got about 950. All right, let's work it out just to prove it, to make sure. See, add up the weights off the periodic table. 6 carbons, 12 hydrogens, 6 oxygens. And 12 from carbon. 1 from hydrogen. And, oh, I wrote this backwards again. I don't know why I'm doing that. 16 for oxygen. When you add up the weights, and gosh, I need more room. It adds up. You should have gotten a total of a little over 180. Let me finish it up down here. 180 should be the total weight. 180.156. That's the weight of all those carbons, hydrogens, and oxygens together. That's how many grams makes a mole. So then looking at our conversion and seeing how it goes, you start off with moles. You put the 1 mole on the bottom. That makes the 180 go on top. And if it worked out, you should have gotten about 950. All right, so this is figuring out what weight of solid do you use to make a certain concentration. Your life could depend on it. Probably not. I hope you don't get stranded in Alaska, starving to death. But hey, if you ever had to make up your own IV, maybe you're just too cheap to go to the hospital. This is how you would do it. I don't recommend that either. Go to the hospital. All right. With that, that's it for this part. If you have any questions, of course, we'll talk about it in Zoom. We'll do some more, a little bit different, maybe a little more complicated. I'll see you on the good old internet soon, I hope. We're done with lecture 27. Yay!